All right, we're going to finish up these notes. All right, we're going to determine whether the given information is enough to prove whether the triangles are congruent. If so, we'll write a congruent statement and state the condition. If not, we'll explain, and then name the type of transformation. All right, so this one here, well, there's nothing more I can mark. So, oh well, triangles here aren't congruent. It's because no side is known congruent. Right, so the triangles are not congruent. Right? If we had one of the sides, then we could use angle side angle or angle angle side. So for instance, if QU were congruent to SU, or excuse me, ST. Right? If this were true, that would be angle, angle, side. I'm just going to put angle, angle, side. Or excuse me, angle, side, angle. If any of the other two sides, so if RU was congruent to RT, or if QR was congruent to SR, that would be angle, angle, side. All right, but since it's not, the triangles aren't congruent. And that's the end of this problem. So let us move on to the next one. All right, here, don't forget that JL is congruent to JL, and that's the reflexive property. Right? And our triangles are congruent. Triangle JIL is congruent to triangle JKL using hypotenuse leg. Oops, I should use two symbols there. I already have one marked. We've got the hypotenuse is IJ and JK, and or IJ and KJ, if I might match them up correctly, and the leg would be JL and JL. All right, so our triangles here are congruent. And that means we can identify the transformation. And this is one of the easiest transformations, I think. So here, triangle JIL maps to triangle JKL by a reflection over the line JL. If I were just to reflect one triangle over that line, I'd have the other triangle, right? That would just be a nice little flip. Right? That one is probably the easiest one to see. That those two are mirror images of one another. They're facing one another. All right, how about this one over here? Well, let's mark that. Okay, so NP is congruent to NP. I made my ends two different ways. This one sort of looks like IP, or I mean AP. Let's make that look like an N. And that's reflexive property. And these triangles are well, if I look too quickly, I might think they're congruent. Uh-oh. Let's look very, very carefully here. I kind of glanced at it thinking I had two angles and a side. I have two sides and an angle. Well, well, well. So, guess what? Not quite in the right location. We need to know a little something else. All right, so again, that side angle's not a triangle congruence postulate. It'd be nice if we knew one other thing. You know, if we knew perhaps NP was an angle bisector, that would help out. But so that's not a triangle congruence postulate, and so we're short a little information here. And so, therefore, a triangle is not congruent. We need to know either one more angle, or she's really not as, or if we knew the MN, so one more angle congruent. Let me put angle pair congruent, or MN congruent to ON. If that were true, then we'd have side, angle, side, and that would work out. If we had one more angle, right, then that would be, depending on which angle it was, angle, angle, side. Yeah, I think it's just going to be, or angle, side, angle, or angle, side, angle, right? But as it stands, we're just a little bit short there. Let's take a look at this one, all right? So we have a congruent side, that's good. We have the congruent angles, those are vertical angles, let's write that down. And did you notice we have these parallel line markings? UW is parallel to YX. And because that is true, our alternate interior angles are congruent. And we actually have two pairs because we have two transversals. So we have one set of alternate interior angles right here. Right? So if you were to extend the line, right, you can do that in your paper if you want, and extend UY, right? So if you extend it here, I'll just do it real quick. Right, so if I extended it, now you can see those are alternate interior angles. If I do the same thing over here, right, these are also alternate interior angles, right? You can kind of see that now too, can't you? Right, so two different transversals and two lines. So I got alternate interior angles. I'm going to undo that just because that's a little busy up here. There we go, and undo the one more. There we go, and just mark the angles so you can see them. So there we go. Right, so those are both alternate interior angles, right? So angle U is congruent to angle Y. Those are alternate interior angles, and angle W is congruent to angle X. I should have really thought out my spacing here. And we'll squeeze it over here. There we go. So these are the alternate interior angles. All right, so we have information here. You can pick, because now we have all three corresponding angles. So if you want to use the angle U and angle W and the UW, you can use angle, side, angle. If you want to use the vertical angles and one of those alternate interior angles, you've got angle, angle, side. So either of them works on this one. Triangle WUV is congruent to triangle XYV using either angle, side, angle, or angle, angle, side. And this is very much like the problem on the other page. Triangle WUV maps to triangle XYV by a 180-degree rotation about point V. And there we go. Let me just fix my word there. Point V. All right, so let's look at the last two here. All right, so we can mark QS congruent to SQ. And that's the reflexive property. And that's all the information we need for angle, angle, side. So triangle RSQ is congruent to triangle TQS using angle, angle, side. And again, do you see how we'd have to rotate it so that this angle matched this angle, and it'd be right about the center point again. So triangle RSQ maps to triangle TQS by a 180-degree rotation about the center. By the way, I could not use the transformations here to show the triangles are congruent because I'm not on a coordinate plane. I really can't show that they're congruent. But once I've proven the triangles are congruent, I can also show you what the transformation would be. All right, I have to actually know that they're congruent first when I'm not on a coordinate plane. If I'm on a coordinate plane, I can use transformations, or I can find the measures and use one of my triangle congruence postulates. I have two ways. Here I have to actually use the our postulates. All right, so this might be a little harder to see because we have two overlapping triangles. So let's separate them out. All right, so on your paper, you're going to draw them out. All right, there's my two triangles. There we go. And we'll label them. This is Z, D, C, and this is B, C, D. By the way, we are not proving the triangles, the little triangles congruent, the overlapping triangles. So we already know these two angles. That corresponds to angle C and angle D over here. Those are terribly drawn triangles, and I traced them. We also know that DC is congruent to DC, right? That right there is the reflexive property. And do we have anything else besides that? I'm not seeing nothing. Let me erase this real quickly. I see one angle. We have one side. And we don't have another side. I mean, it's an isosceles triangle, so we know this is congruent to this, these little pieces here, but those pieces aren't enough. Here's a pair of overlapping that's just not enough. And it would have been a nice reflection, too. Well, you know what? I would prefer this be congruent because I'd like to review the reflection. So let us say that those two are congruent because I'm not seeing nothing else. Otherwise, I'm short information, and I find it more interesting for us to go over it. So let us just say that those two are congruent, just because, well, it's my problem, and I can do that. All right, so that's not the right one to choose, is it? And you can see, if you look at the picture, that if I were to mark those, that would not be the right choice. So instead, let's make the angles congruent. Then I don't have to worry about it. All right? It's hard to choose the right side. It would have to be ZC and BD if I wanted side angle side. But now, if I say those are congruent, just because I said so, we've already had ones where we were short information. Now we can say angle, angle, side. So because I am deciding, okay, so it's my given, Mrs. Mashagna's given, right? Angle Z is congruent to angle B because I said so. And if that's true, then triangle ZDC, ZCD is congruent to triangle BDC using angle, angle, side. By the way, you don't get to do that on a problem on the homework. Only I get to do that on a problem. Triangle ZCD maps to triangle BDC by a, I hope you see that would be a reflection about a vertical line, line through point A. Can I squeeze it in? Through point A. There you go. There's the last little piece. Through point A. All right? And that's only because I decided to be so. If I'm missing something here, like maybe it's, maybe I can't see it on the screen, and I've missed a congruency, I'll let you know in class. But as it stands, I've got two. Unless I see something else or something comes to me, I've only got two. I do have these vertical angles, but that don't really help me either. So, because they're inside the triangle, they're not part of the bigger triangles. So if something comes to me, I will let you know. But otherwise, I'm just going to make it that just because I said so. All right, and it's good enough for us for our review anyhow. All right, let's continue on, and this is not going to be much longer. I know my first podcast was a little long. Just a couple minutes. I want to do one simple little problem. This is so simple. It's not in your notes, but here's a real world problem. Point A is the same distance from point D as point C is. So if point A is the same distance from point D, well, if I could draw a straight line, as point C is, they must be congruent. North Llano Street meets Route 290 at a right angle. So North Llano Street is that one that's going right through the middle of the triangle there. There we have a right angle. Okay, so that's perpendicular. This, of course, North Llano Street is congruent to itself. What triangle congruence postulate could be used to prove that the triangle created by points A, B, and D is congruent? So triangle ABD is congruent to triangle CBD by, hope you see it, it's hypotenuse leg, triangle congruence. Damn. So easy cheesy lemon squeezy problem there, right? I think that was pretty easy. Right. A little quick review, and then you have a mini quiz to take now that you've heard me talk for 36 minutes. All right, methods for proving triangles are congruent. Side, side, side. 3 sides of one triangle are congruent to 3 sides of another triangle. The triangles are congruent. Side, angle, side. If 2 sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. The included angle is the angle formed by the sides being used, right? So if you were to follow the sides, they have to meet at this angle, right? If I follow the sides together, where do they meet? They meet at the angle. If that angle where they would meet, if I follow them, is congruent, you have side, angle, side. If it is any other angle, no good. Only difference between angle, side, angle and angle, angle, side is where the side's located. So if 2 angles are the included side, so if the 2 angles are on either side of your side, of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. For angle, angle, side, it's 2 angles and the non-included side, right? So you can see from the diagram there, it's just some other side, not the included one. If they're congruent, then your triangles are congruent. And then finally, hypotenuse leg. If the hypotenuse and leg of one triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. You can't see the bottom of the page. Let me fix that. There you go. So either leg of the corresponding legs are used, right? So long as it's the hypotenuse and the leg, all right? And make sure it's a right triangle. Not it kind of looks like a right triangle. You have to know it's a right triangle. You have to be told that it's a right angle or have some way to show it's a right angle in your right triangle. All right, and those are it. And that's the end of this podcast. Okay, so do your best on the quiz. I suggest you draw the pictures. You won't hear me talk after this. I suggest you draw the triangles and mark the congruent parts. They are not marked necessarily for you. All right, they are given to you but not necessarily marked. And then you will choose from the you have your 6 choices, right? Side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, or not congruent, right? Just like we did in class. All right, good luck with that, and bye for now.